Okay, so just a moment. There we go. So in this lab, I'm going to be making something different. I'm going to be using diodes to create an AC to DC power converter. Now, this is called a bridge rectifier. You can kind of think of it as use rectifier diodes to create a bridge for AC to DC. Now, I assume you know what AC to AC is and DC is. DC is direct current, which means the current is going in one direction only. It goes in a straight line. AC is alternating current. It goes back and forth with each other. And AC is what's on our power lines. It's what comes out of our power outlets. It's not a natural thing. It's man-made. And it's purely, and that's the only way that you can get. That's the only. That's kind of a key feature of AC. It can go a lot further. I don't know. It's hard, but you can't light up things like an LED with them. And so you may wonder, well, how do we plug like a? No one has this, but they exist. An LED flashlight into the wall. Yes, you plug a flashlight into the wall. Doesn't make sense, but they exist somewhere out there. I'm sure they do. But anything you plug into the wall that emits light, just to say that, you may wonder, like, well, how do we light up those LEDs? I mean, you can't light up LEDs without DC. Well, we don't light them up with AC. We light them up with DC. We do that using a bridge rectifier. Bridge rectifiers are kind of really kind of cool things, and you may think that, you know, it just could take one diode. You could think that it takes one diode. You've got current going through one way, and it only can't come back. So if the AC current goes through, which it can, it couldn't come back, right? Well, sure, but there's a little bit of a problem here. You can't get you only have one, terminal then. There's no such thing as there's a positive and negative in DC. In AC there isn't necessarily. There has to be a positive and negative in DC, and you only have one output here, so you don't have DC. You've got something else. You've got something not working, actually. I don't remember what happens, but it doesn't do anything. It doesn't work for that purpose. So, what we're going to do, we're going to take 4 diodes. 2, 3, 4. I'm not going to demonstrate this with AC because I don't feel comfortable just hooking up 120 volts AC directly to this thing and demonstrating it on an LED, like, oh, look at that. Because I don't want to do that. I don't want to stick wires in my electrical outlet. But you're gonna have to go with me on this, and I'll show you the theory behind it, kind of. Let me grab my whiteboard real quick to show you. Okay, so I don't have a marker. Yes, I do. I'm sorry. I'm sorry about that. Okay, so let me grab my whiteboard here. Let me show you what's going to go down. Zoom out a bit here. Okay, so before I make it, I'm going to draw it for you. The camera's upside. I'm looking at an upside-down view, so I'm getting a little confused here. But oh, I'm just gonna draw it like this. Okay, so we have this. I'm gonna draw you the schematic. I'm gonna draw you the schematic of a diode. It makes a lot of sense. We've got this. We have a triangle. And there's a line on the triangle. You can just think of that as meaning like no passing or whatever. You can't pass the diode. So I'm gonna use the schematic symbols here. Sorry if the writing's not neat. I'm not known for writing neatly. And then we get one more right here. Okay, so there's the schematic here. It's not very neat. I'm sorry about that. We get now here. Doesn't even look like anything in the camera. I'm very sorry. Okay, so let me just draw some arrows here. I forget that the camera's backwards, so I'm very sorry about this. I'm just gonna explain. Okay, so in here, we've got AC current going in here and here. So we're just gonna, we're gonna follow the AC current. So we've got AC current, which is, you know, going back and forth, back and forth, and back and forth, blah, 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 whatever. It's going in here. It can take two paths now. It can go here, which it's just gonna get blocked. So it's gotta find some other way to go. It goes through here. Now we have one. You know, we've got a single wave. That's what it's called, a single wave. It's not DC. It is single wave, and it is not. I don't think it's very useful power, if I remember. However, it is positive. The reason it's positive, I don't remember why. It's positive though. I believe it's positive because oh yeah, okay, never. Yeah, that's not the only reason that's positive. We also have AC coming in here, and it's going through there, and it's causing, and it's adding, and we're adding the waves together. And you add the waves together, and we get positive. That's how the positive is formed. I'm sorry. So you have that going on. But what about negative? Well, we have to get what we have to do is we have to get it returning to positive. But AC doesn't have positive and negative, if you remember. So we just have to have it going through two diodes a diode that it can't come back, and it can't come back. So it comes back as DC, and it goes through the diode again. It doesn't come back as necessarily as DC, but it gets mixed with the AC, causing it to become AC, kind of. It's hard to explain, but that's what it is. So we're gonna make it now. That was a really clumsy segment. I'm gonna keep it in there anyway. I'm gonna use these diodes. Let me just zoom in. So remember our schematic. Just lay these out real quick. I'm just gonna twist these together, by the way. I'm not gonna solder, I'm not gonna, use a breadboard or anything. Most of the time you'd solder or use a breadboard when you do this, but twisting will be okay here. Okay, so we got this. So we're just gonna take this diode, twist it with its buddy. It's not gonna be the prettiest of rectifiers ever made. Yeah, I've got stuff flying everywhere. I'm not known for having the most, dexterous hands. Not dexterous hands, I'm not known for being good with fine motor movements. Challenge of mine, which makes it hard to be in electronics, but, you figure it out. It's completely backwards. Whatever. Okay, we got the... No! That was awful. Never twist stuff like that. It's bad. This is the worst twisting you're ever gonna see. And then we're gonna twist this over here. You get the point. I'm determined to do this now, though, so excuse me while I be determined. Okay, here we go. Here we go. Now, remember how to twist wires. As you can see, it didn't end up as a square, it ended up as a loop, but you know what, that's okay. So, it's the most inflexible one in the world. We got our AC going in here, AC going in here, well, okay, theory. Take these two wires and you've got DC positive going out here, DC negative going back in there. I was going to make one out of these, but I don't want to ruin them. I like the way they look too. I know that doesn't matter, but I don't want to ruin my hands because that wire is much thicker. So I'm going to untwist this and tell you about why we don't see this everywhere. And if you have looked around, you don't see four diodes kind of in a not triangular, square pattern everywhere for this. It's because we've packaged them. Ever since integrated circuits, everything's been getting smaller and smaller, and we've been putting things in smaller packages, too. Not ever since integrated circuits, but ever since, you know, just miniaturization is, or making things smaller is kind of making things more compact, more efficient is the human nature. So, I'm not gonna undo the knots in them right now. In fact, I'm not gonna do that ever. Human nature is to, you know, make things more efficient, kind of. So, we, you know, packaged it up. Just like we packaged up 555 timers, we kind of packaged it up. It's not as much of an integrated circuit because it's up for general use in homes, which is 120 volts AC. You're going to need more than just those little diodes. So, I've taken apart many circuits towards over the past, you know, months and stuff. And, you know, you find bridge rectifiers in packages like this. They tend to look like that. Here's a smaller one. They've got a little notch in the corner, and they also will tell you the pin out of them. So as you can see on this one, or maybe you can, maybe you can't, I don't know, I'm sorry if you can't. There we go. You got a negative, a positive, an AC, and ACN. The AC is there in the middle, and the positive's on the right, at the side of the notch, and the negative's on the non-side of the notch. And that's the outputs. So, you'll see these in places. These can get very hot when you're using them in the day-to-day applications. Normally you're going to use big diode. In industrial uses, they use huge diodes, like that big around, because they can be that big around, and they have them connected to each other with they're not twisted, I'm going to tell you that. And they go to each other to get us DC, which is the most usable one we have. We do run some things off AC, like if you've ever seen a box fan, that's an AC motor. There are such things as AC motors, and when DC is not applicable, when things need to go further, we use AC. And an example of using DC or non-standard AC, an example of not using AC in a or using AC is on a longer subways. They tend to use AC as opposed to DC. DC, because AC can travel much further, because it's alternating and it's transferring energy. I believe that's why. If not, I'm sorry, don't quote me on that. That's it for rectifiers in this lab. Sorry, it wasn't really much of a demonstration, but it's an important topic to know in my opinion. Thanks for watching. I'll see you guys next time. Bye.